In this video, let's solve a challenging problem from the world of GM. Here's the problem. Find the value of n such that this term may be the GM between a and b. And this term is, in the numerator we have a to the power n plus 1 plus b to the power n plus 1, and the denominator has a to the power n plus b to the power n. So they're saying there are two numbers a and b and we don't know these numbers. And we need to find the value of n such that this term becomes the geometric mean between these two numbers. Okay, we want to give this a shot. Pause the video, try it on your own. Okay, so let's do this together. One thing that we know is GM is actually equal to the square root of these two numbers a and b. So let's start from there. This term is actually equal to the square root of a and b. If we can figure this out, if we can solve this one, we can get the value of n. So this looks a little hairy, but will also be very rigorous. So what's the next step? Let's cross multiply. So we get a to the power n plus 1 plus b to the power n plus 1, and this denominator moves to the right hand side. So square root of ab times a to the power n plus b to the power n. Alright, what should we do next? We can distribute square root of ab to both these terms. But before that, let's look at the powers. Here the powers are n plus 1, n plus 1. Here the powers are n and n. And what are the powers here? Well, this is the square root. This means the powers are half and half. So let's do that. Now let's distribute. So this becomes a to the power n plus half, b to the power half, plus here we have b to the power n. So this becomes b to the power n plus half and a to the power half. So we have two terms here and two terms here. What should we do next? We can move these terms, we can rearrange them. So we'll get a to the power n plus 1 minus the bigger term that has more a's, a to the power n plus half, b to the power half. We moved this term to the left side and we brought this term to the right side. So we get minus b to the power n plus 1. What can we observe? Can we take something common? Here we have a to the power n plus half, and this power is half more than that. So we can take a to the power n plus half common actually. And similarly, on the right hand side, we can take b to the power n plus half common, because n plus 1 is half more than this. So let's do that. A to the power n plus half times, here we are left with a to the power half, minus, here this goes, we are left with b to the power half. That's equal to b to the power n plus half common times a to the power half minus b to the power half. We get a very neat a to the power half minus b to the power half on both the sides. But we have to be careful, we can't just cancel these terms. A more mathematically accurate way would be to bring both of them on the same side. So let's do that. We get this minus this. Now we can take a to the power half minus b to the power half common, and we get a to the power n plus half minus b to the power n plus half times a to the power half minus b to the power half equals to 0. So here's what we have. We have these two things and they're multiplied and we get a 0. When do we get a 0? When we multiply things. Either one of them is 0 or both of them are 0. So we can split this and we can say that from this equation we can realize either this thing equals to 0 or this thing equals to 0. And we can solve both of them independently and we might end up with some value of n. So let's see. Which one should we start with? Let's take this one. This doesn't have an n, so we can wrap this up first. This is a to the power half minus b to the power half. Rearranging will give us a to the power half equals to b to the power half. That's a equals to b. Square root of two numbers are equal, which means the numbers are equal. So here we get a equals to b. Let's pause for a minute and see what this means for us. When two numbers are equal, what happens to their GM? Let's take an example. If two numbers are both 10, what is their middle value? Well, their middle value is also 10 because they're not moving. So when the two numbers are equal, their GM, in fact their AM as well, but their GM is the same. The GM is the same as these two numbers. Let's verify this result. When these two numbers are equal, what happens to this expression? Well, let's replace b with a. We get a to the power n plus 1 plus a to the power n plus 1 upon a to the power n plus a to the power n. So this is what we get. And we can simplify this. This is twice of this by twice of this, and 2 gets cancelled. A to the power n in the denominator, a to the power n plus 1 in the numerator. All the a's get cancelled and we are left with just one a. This expression is also equal to a, which means it's equal to the GM, which means this is true. This may be the GM between a and b when these two numbers are equal. But this is a trivial case. this is a very special case. This case actually doesn't care about n gets cancelled out, and this is true no matter what. But what happens when the numbers are not equal? Can we find a value of n which makes this the GM between a and b even when a and b are not equal? I think this part should give us the answer because this is where the n is. So let's simplify this part. Here we have this difference equals to 0. So we can rearrange this and say that a to the power n plus half equals b to the power n plus half. And we can divide these two terms. We can get a by b to the power n plus half. That's equal to 1. Now how do we solve this one? We have something to the power something equals to 1. And when does that happen? Well, one case could be when we have 1 inside the bracket. You can raise 1 to any power and you will still get 1. So this means either a by b that's equal to 1, or if you raise this number to the power of something and you're getting 1, this means the power could be 0 or this power is 0. Think about it. You raise any number to the power 0, you will get 1, except 0 of course. So either a by b is 1, which means a equals to b, and we have covered this case, so we'll ignore it. Here's our n, so let's look at this part. N plus half equals 0, which means n is equal to minus half. Now this is interesting. What we have got from all of this is when n is minus half, this is the GM between a and b. So assuming that the numbers are distinct, our value of n is minus half. Let's see what's so special about this value, n is minus half. Let's try plugging this back into our initial expression. Let's make some space. Okay. So if we put n as minus half, what do we get? We get a to the power minus half plus 1 plus b to the power minus half plus 1, and in the denominator we get a to the power minus half plus b to the power minus half. Let's simplify this. Minus half plus 1 is half, which means this is square root of a, and minus half plus 1 here we have half, which is square root of b. So in the numerator we have square root of a plus square root of b. In the denominator we have a to the power minus half, that's 1 upon square root of a, and here we have 1 upon square root of b. So this is what we get, root a plus root b by 1 by root a plus 1 by root b. Let's simplify this further. For the denominator we can take root a root b as the LCM. This is what we get, root a plus root b divided by root a plus root b upon root ab, and this gets cancelled, root ab moves to the top, and finally we get square root of ab, which is what we wanted. This means that for n as minus half, this expression actually becomes root ab, which is our GM between these two numbers. Now here's what I feel. This problem was less about the GM. Just because this expression simplifies to root ab doesn't mean that we're using a lot of what we know about GM to solve this problem. In fact, in math, for these tougher problems, it's always the case that a lot of things that we have learned in the past, in the previous chapters or grades, actually come in handy more than what we're learning in this current grade. So it's always recommended that you brush them up whenever you can.